Imagine, just for a second, a computer that literally no single person or corporation actually owns, yet millions of people completely trust it to move billions of dollars every single day. Welcome to today's Explainer. We are looking way past the usual chatter about digital currencies, and we're diving right into the invisible, global machine that's actively powering a decentralized internet. We're talking about a system running thousands of applications and global financial services, and it's doing the whole shebang entirely without a bank or some corporate CEO pulling the strings.
Okay, let's dive into this because it really is a fascinating paradox, right? How exactly do you move billions of dollars securely without a central bank pulling the levers? Or, how do you run incredibly complex software without a massive tech giant hosting it? Well, the answer is Ethereum. Let's unpack exactly how this entirely ownerless machine actually works in the real world, and why tech visionaries honestly believe it's one of the most absolutely crucial leaps forward since the internet itself.
So here is our roadmap for today. We'll start with what is Ethereum, move into the smart contract revolution, check out real-world applications, look at powering and securing Ethereum, and wrap up with risks and the future. Don't worry, we're keeping this totally structured and entirely jargon-free.
All right, Section 1. What is Ethereum?
And this brilliantly illustrates a really common mix-up. If you follow this space, you know Ethereum isn't just another cryptocurrency trying to grab your attention. A lot of folks just lump Bitcoin and Ethereum together, but they are totally different beasts. See, Bitcoin was primarily designed as digital money, a store of value, kind of like digital gold, right? Ethereum, on the flip side, was built from day one to be programmable. So instead of digital gold, think of it as the base operating system for the entire blockchain world. It's the foundation where developers can build totally new stuff.
Actually, at its very core, Ethereum is really just a giant global computer. So instead of a massive tech giant hoarding all their servers in some giant air-conditioned warehouse somewhere, Ethereum is completely spread out. It lives across thousands of individual computers all over the planet. And because everyone pitches in to maintain the network, there is absolutely no single point of failure and definitely no single central company calling the shots.
Moving right along, Section 2, the smart contract revolution.
So the crucial point is, without this next piece, Ethereum would essentially just be a really slow calculator. Enter the smart contract. It sounds a bit complicated, but it's really just a computer program stored directly on the blockchain. And the absolute magic word here is automatically. These contracts execute exactly as they're written the second specific conditions are met. We're talking zero middlemen, no manual approvals, and definitely no waiting until Monday morning because the bank is closed over the weekend. It is pure automated trust. It's a real game changer for how we transact.
Just picture two friends placing a bet on a football match. In the normal world, you'd need a bookie holding the cash, and they're inevitably going to take a massive cut. But with the smart contract, it is just 3 simple steps. Step 1, the bet is placed and the funds get locked right into the code. Step 2, the match ends and the smart contract automatically checks the final score from a trusted data feed. And step 3, boom, the winnings are instantly sent straight to the winner. Once those rules are coded in, nobody can mess with them. Same exact logic for buying a concert ticket, by the way. The second you pay, the ticket hits your wallet. Literally zero middlemen.
Okay, Section 3, real-world applications.
Because developers now have the keys to this incredible global computer and all these automated smart contracts, they are building some truly wild decentralized applications, or dApps for short. For instance, take DeFi, or decentralized finance. This lets you lend, borrow, and trade completely without a bank. You can literally earn interest purely through code. Then you've got NFTs, which totally flip the script on digital ownership for things like art, music, or virtual real estate. Gamers can actually own their in-game assets now, rather than the studio owning them. And of course, stablecoins. These are essentially digital dollars that let you shoot money internationally in just a few minutes, instead of waiting days for some clunky traditional wire transfer to clear. And it's really not just for digital stuff either. We're actively seeing the tokenization of real-world assets. Just imagine taking a piece of physical real estate, company stocks, traditional bonds, or even a tangible painting, and representing it digitally right on the Ethereum network. It basically makes proving you own something and then transferring it infinitely smoother and faster than the paper-heavy, bureaucratic systems we're all stuck using today.
Let's move to Section 4 and see how this builds, powering and securing Ethereum.
So, we've talked about all these amazing applications, right? But how do you actually keep an ownerless global computer running smoothly and securely? Well, to peek inside the engine room, we have to ask a pretty critical question. What exactly is Ethereum gas? Look, if you've ever used this network during a massive bull run, you've definitely felt the sting of it.
But understanding gas is absolutely essential because it's the fundamental economic reality of the blockchain. Simply put, gas is a transaction fee. It's paid in ETH, and it is required for every single action you take on the network. Why? Well, because you have to pay the validators who are doing the heavy lifting to process and secure the network. If you're just doing a basic, simple transaction, it only costs a little bit of gas. But if you're interacting with a super complicated smart contract that requires a lot of processing power, yeah, that's going to cost a lot more.
The best way to look at it is to think of gas like paying your electric bill to keep a computer running. If you want to use this massive global computer, you gotta pay for the computing power you're using up. It makes sense, right? Without gas, there's literally zero financial incentive for anybody to process these transactions, and the entire Ethereum network would just grind to a halt. It simply couldn't function.
So that brings up the next question. Who exactly is processing all these transactions? That would be validators, operating under a clever system called proof of stake. You can pretty much forget about the old days of crypto miners burning through entire countries' worth of electricity with giant energy-hungry computer rigs. Instead, participants in this system literally lock up their own sheath to help secure the network and verify transactions. Because it's their own hard-earned money on the line, they're heavily incentivized to play by the rules. In return for maintaining the blockchain, they earn rewards. And crucially, this is a big deal, it uses significantly less energy than those old clunky mining setups.
When you put all those pieces together, you start to quickly understand exactly why the cryptocurrency ETH actually has value. We're not just talking about some speculative coin here. ETH is the required fuel for this entire ecosystem. You need it to pay your transaction fees, developers absolutely have to have it to deploy their smart contracts, everyday users need it to power their interactions with dApps, and validators need it to stake and secure the network. Logically, it's pretty straightforward. As more developers and users flock to Ethereum, the demand for this essential fuel naturally goes up.
And that brings us to our final part, Section 5, Risks in the Future.
Now, what's really interesting about this is that it's definitely not a perfect utopia. The growing pains for this technology are very real, and we have to balance all that excitement by looking at the real-world challenges with strict objective scrutiny. Those gas fees we just talked about, they can become prohibitively expensive when the network is congested. Plus, since there's no central bank you can call to reverse a transaction, crypto scams and fraud remain a massive threat. Add in the reality of buggy smart contracts causing irreversible financial losses, extremely high price volatility, and constantly shifting global regulations, and it is crystal clear that users absolutely must proceed with caution and do their homework.
But even despite those risks, thousands of experts and developers view Ethereum as the very foundation of Web3. So Web3 is basically envisioned as the next huge generation of the internet. We're talking about an internet where users actually own their own data, their finances, and their digital assets, all built on decentralized foundations rather than walled-off corporate servers. And right now, Ethereum is undoubtedly the heaviest hitter pushing toward that envisioned future.
Which ultimately leaves us with one massive, lingering question. Will this decentralized global computer become the permanent, invisible foundation of our digital future, fundamentally replacing all those traditional middlemen across finance and tech? Or will the sheer weight of technical bugs and massive market volatility hold it back from true mainstream adoption? The final chapter of Ethereum is literally being written right now by the thousands of people building on it every day. Thanks so much for joining me for this explainer, and as always, keep questioning the systems that run our world.